Hey everyone, so we're going to do another video where we're going to look at 4 hard SAT math questions. I got a lot of feedback saying that they wanted harder questions. So in this one, we're actually going to be looking at some hard questions that were submitted by a subscriber. If you want to see your questions in a future video, just fill out the form in the link in the description and I can take a look and see if it would be suitable for another video. So let's jump into this one. We are given a f of x is equal to this standard form quadratic where we don't know a and we don't know c, but we do know b. And it says that it's in the xy plane. It opens upwards. It tells us that it opens upwards. So immediately we know that a is going to be greater than 0 at least, okay? We know that. And it has a vertex at the point hk, which is pretty standard. And it tells us if k is less than 0, and we know that f of -9 is equal to f of 3, then which of the following must be true? And it gives us some criteria for C, gives us some criteria for A, and then it's asking us if both of them are true, one of them, or neither of them are going to be true. So there's a lot of information here. I always like to start these questions off by visualizing them. Visualizing is a great way to kind of analyze that information that we've been given in the question and break it into smaller, more bite-sized bits of info. So we've got our y and our x-axes, and the thing about this function is that we actually don't know a whole lot about it. So we're gonna just kind of draw, okay, we're gonna label some arbitrary value here, and we'll call this f of 3 or f of -9. So we know that at a value of -9 and at a value of 3 on our x-axis, it's going to have that same y value, right? Let's move that. Let's move this a little bit higher. It's going to have the same y value, right? And I just chose some random 2 points here for our y value, right? But what we do know is that it's going to have its vertex in the middle of these two y values, right? Because this is a quadratic function, so it's going to have that symmetry. So we know that that vertex, or h actually, will be right in between -9 and 3. So we can just add those together and divide by 2, or you can do this in your head, right? We can see that that's going to be at -3. We know that that's our value of h because that's the x value of our vertex. So we know that at -3 it's going to have some kind of vertex here, but we don't know where exactly it's going to be, right? Because it could take place like up here, it could take place down here, and that's going to depend on what our value of A and what our value of C is, right? We also don't know the value of K, right? So lots of unknowns, so it's kind of hard to wrap your head around which of these must be true. For this type of question, my personal preference, I see a lot of unknowns. I see a lot of ways that I could imagine this, and that's just a lot to process. So when I have that much information, I personally like to resort to an algebraic approach. So that's how I'm going to be approaching it in this video. Not how you have to approach it, but this is what I think would be the most helpful for me. So let's take a look at this. Okay, we know that in vertex form, our quadratic is going to take the form of sum a times x. We know h is -3, right? If we know that h is -3, then it's going to be x plus 3 because we've got x minus h. This is squared plus k. Okay. We can also, let's just expand this to make it look like our standard form. This is going to be x squared plus 6x plus 9 plus k. Factor in our a, and we're left with ax squared plus 6ax plus 9a plus k, right? And we know that y we just expanded our vertex form, but we know that it also takes the standard form of what it's given in the question, which is ax squared plus 4x plus c. And I wrote that right below here because you can kind of see that the coefficients have to be the same here, right? Makes sense. Okay, our coefficient on our second degree term is still going to be a, but we also know that the coefficient on our first degree term has to be equal to the one that's given in the question. So we can see here that 6a has to be equal to 4. And similarly, we can see that our value of c, or our constant terms, have to be the same as well. So we can also write an equation that says 9a plus k has to be equal to c. Okay, very simple solving. We can see a is 2/3, right? Dividing both sides by 6 and simplifying. Okay, if a is 2/3, then we can solve this, right? Or, well, we can plug this in at least and simplify. 9 times 2/3 plus k equals c. Okay, this is going to give us 6 plus k is equal to c, right? Okay, and then it also says that in the question, tells us if k is less than 0, okay, then what has to be true? Well, when k is less than 0, okay, well, we know that k is just c minus 6, okay? So if k is less than 0, that just means that c minus 6 is less than 0, or c is less than 6, okay? Make a bit more space here. So we can see our value of c is going to be less than 6, and we actually solved for our value of a here as 2/3, okay? This is the value of c when k is less than 0, right? Because that's what it tells us in our question. So we can look at our options now. We see that c is less than 0. Well, not necessarily true, right? Because it's saying that our solutions can be satisfied, like we can meet the criteria that's been given in the question as long as our value of c is less than 6. So that means that we could have a value that's greater between 0 and 6 and it would still work. So c, or number 1, isn't true. A has to be greater than or equal to 1. Well, we solved for a actually. We saw that it was 2/3. So that's also not true. So by process of elimination now, we can see that neither 1 or 2 are correct. So our answer D would be the correct one. Okay, let's move to the next question. Okay, this one says, okay, in the xy plane, a parabola has a vertex at 9 minus 14, and it intersects the axes, or the x-axis, at 2 different points. And it tells us that it's taking on the standard form, blah, blah, blah. And what could the value of the sum of our coefficients be? Okay, whenever I see a vertex, or a point for a vertex, my mind instantly goes to how can I write this parabola in vertex form? So that's just how we're going to start the question. So y is equal to x. It's at positive 9, so it's going to be x minus 9 squared. And our value of k is minus 14 here. And similarly to the last question, let's just expand this, right? See what we can do here. Okay, because I see that we also have a standard form given in our question, and I want to take the information that's been given to me for the vertex form, kind of see how I can bridge the gap between the 2 different forms. So I've got a times, this is going to be x squared minus 18x plus 81 minus 14. Expanding this again, I'm going to get a times x squared minus 18ax plus 81a minus 14. And, okay, well, similarly to the last question, we can kind of see what our coefficients for A, B, and C have to take on, right? Because this is going to be our A coefficient. our coefficient attached to our first degree term will be b, and same thing with the constants. They will be equal to our c. So, I mean, from the first equation, we get a equals a. That doesn't help us. But the second one, at least we get b is equal to minus 18a. And from our last equation, we get c is equal to 81a minus 14. So then it's asking us what's the value of a plus b plus c. Okay, so we kind of have three unknowns here, right? And we sort of have three different equations, right? So it's saying that we're looking for our value a plus b plus c. This is going to be equal to one of our solutions here. So that's going to be one equation. This is going to act as our second equation. This is going to act as our third equation, right? Three variables, three unknowns. So it seems like it will be solvable. Okay, so a plus b plus c from our first equation, well, that's going to be equal to a plus, well, we said b is minus 18a. So this is going to be minus 18a plus c. C is 81a minus 14. Okay, simplifying this, we can do this, right? This is going to be, and I've done this math already, 64a minus 14. Okay, and like we said, from our equation 1, it's kind of like a half equation because we don't actually know what a plus b plus c equals yet. But we know that it's going to equal one of the solutions. So what we're going to be doing here is we are going to be looking for one of these solutions that makes this work. So we know that all of these will work. We will be able to find the solution for a, b, and c by plugging in any of these values. We'll just get different values, but what it tells us in the question is that the parabola has a vertex at x9, y negative 14. So that means that our vertex is below the y-axis, and it tells us that it intersects the x-axis at 2 points. That tells us that the parabola has to be facing upwards. I'll visualize what we just said as well. Y, x, right? So very approximately, we have 9 minus 14 here. And it tells us that it's going to intersect the x-axis twice. So that means that our parabola has to be facing upwards, something like that. So if our parabola is facing upwards, that means our value of a, it has to be greater than 0. So let's try plugging in different solutions here, a, b, c, and d, and see which value will give us an a that's greater than 0. Sorry, a is greater than 0. Let's try option A. So, okay, option A is minus 23. This is 64a minus 14. So this would give us a is equal to, and then minus 23 plus 14 is minus 9 divided by 64. So minus 9 over 64, which is less than 0. So it's not a. Oh, let's scroll down a bit. Okay, b is minus 19. 64 minus, a minus 14. Right, I can see minus 19 plus 14. Right, that's going to be minus 5. So our a is going to be minus 5 over 64. Also less than 0. Not what we're looking for. And you might be able to see a pattern here that whatever our answer is on our left-hand side, well, if we're going to be adding 14 to it and then dividing by 64, well, we need our value to be something that is that's less than or greater than negative 14, right? Or something that has less magnitude than 14. So if we look at our solutions here, we can quickly see that like D would be the only one that satisfies that. You could try plugging in your answers for C as well, but you'll quickly see that C is going to produce an answer of A equals 0, and D will be a positive answer, right? So just for sake of time, you can quickly see the pattern and then jump to, well, D is going to be the one that produces a positive value of A. If you're not quite sure, I would just go through C and D and also try to verify that for yourself. Let's look at another one. Okay, we get a question that says, okay, for the function f, for each increase in the value of x by c, where c is a positive constant, the value of f of x increases by a factor of 27. So which of the following equivalent forms of the function of f displays 1 over c as a coefficient of x? Okay, this one looks a little bit confusing just by the wording of the question, but let's kind of break this down. Okay, well, which of the following functions displays 1 over c as a coefficient of x? Okay, so if I look at my different possible solutions here, I can see the coefficient on the x. So the coefficient on a, for example, right, half, well, this would be 1 over c, right? So this means that for option A, c would be equal to 2. So let's try to put some numbers to this, make it make a bit more sense. It's saying that for each increase in a value of x by 2, so every time we increase x by 2, then f of x should increase by 27. So for example, if we were to plug in f of 0 right now, then for option A, we would get 48 times, okay, well, that's going to be 3 to the 0. This is going to be 48. Okay, so if we were to increase our value of x by 2 in this case, right, because our coefficient is 1 over c, then that means that our next one should increase. It should be 48 times 27, right, because it increases by a factor of 27. So if I were to plug in now 2 as our value of x, we would get 3 to the, well, this is now to the power of 1. So this is actually just going to be 48 times 3. So I can see that A is not correct, right? Because I'm looking for something that takes our f of 0, I increase by a value of c, and it's 27 times the first value. So let's look at option B now. Okay, option B, I can see that our 1 over c is equal to 1/6 here, or c is equal to 6. Okay, so let's do the same approach, right? F of 0, I can see would be 48, because our second term is just going to be 3 to the power of 0, which is 1. So that means that if I do f of 6, it should be 27 times 48. Let's check that. 48 times 3 to the power of 3. 3 to the power of 2 is 9. Multiply that by 3, I get 27. So this is 27 times 1/6 times 6 is 1. So there you go. You can see here that we increased. Oh my God, sorry, my dog is going crazy. So this is 48 times 27. Let's do one more just to double check that this pattern is holding true. It's not just a fluke. So 6 plus, okay, well, if we increase by another value of c, which is 6 in this case, that's 6 plus 6 is 12. This will be 48 times, we've got now 27 times, and now 12 over 6 is 2. So it's going to be 48 times 27, right, our value of f of 6. And it's going to be increased by another factor of 27. So it checks out. Option B in this case is going to be our correct answer. Took a quick little break, okay? Quick little dog break before the next question. This is the dog. Oh, she says, let me down, let me down. Okay. Okay, let's look at the next question. Okay, we get a quadratic x squared minus 34x plus c, and it's equal to 0. It tells us that in the given question, c is a constant, and the equation has no solutions, or no real solutions, if c is greater than n. What's the least possible value of n? Okay, so this one, we're looking at when this quadratic has no solutions. So immediately I'm thinking discriminant. So we know discriminant b squared minus 4ac for no real solutions has to be less than 0. Okay, our b squared is going to be minus 34 squared minus 4 times 1 times, we don't know c yet. And then we get, okay, well, 34 squared is going to be 1,156. Okay, and this is greater than, let's move to the other side, 4c. And we get 289 is greater than c. So it's asking us what is the least possible value for n, right? Well, we can see that this is when c is greater than n. So n is 289. And we can verify this with Desmos too, right? If we look at Desmos here, I've already put this up. We can see this is our quadratic right now with c equals 0. And if you keep increasing it and increasing it, eventually we'll hit no solutions, right? And you can see that we just hit no solutions there, right? So let's keep decreasing this until we find the lowest possible values. So you can see here I'm at 290, okay? And it's got no solutions, right? Let's check 289. 289 has one solution. So it actually has one solution. So that means that to get no solutions, I've got to go over 289, 290. So that checks out, right? We're saying that c has to be over 289, right? So I think we can assume that in this question that c has to be an integer, because if that wasn't a constraint on this question, then you could argue many answers here. Or actually, yeah, no, you know, that makes sense. What is the least possible value of n? Yeah, 289 should be would be the right answer. Just don't overthink this one. Yeah, okay. Again, if you have questions that you want to see in a video, I'm going to start a new series for doing questions from subscribers. So fill out the link below, and yeah, see you in the next one.